Good morning, this is Dr. Sailaja, working as Associate Professor of Mathematics, MLR Institute of Technology, Hyderabad. Today we are going to discuss about the application of discrete and continuous random variables. So here, binomial distribution, Poisson distribution, normal distribution. So here we study about these three distributions. In binomial distribution, this is a discrete distribution. Why it is discrete, we discuss later. Poisson distribution, this is also discrete distribution. And normal distribution, this is continuous distribution. Now we discuss these probability distributions one by one. Already we have discussed in previous class what is a discrete random variable, what is continuous random variable and their properties. So here what are the applications of discrete and continuous random variable are. The first one is binomial distribution. Here capital X is a discrete random variable and its probability mass function of binomial distribution is defined as probability of capital X equal to X, or in short way write it as P of X equal to NCX P power X into Q power N minus X, where X takes the values 0, 1, 2, 3 and so on N. So here in binomial distribution, X takes only finite number of values 0 to N. So what is X, what is N, what is P, what is Q? So in a random experiment, already we know that the sample space is a set of all possible outcomes of a random experiment is a sample space. So in binomial distribution, we take the sample space as only two outcomes, either success or failure. That means the random variable X takes only success or failure as the outcomes. So this is the sample space. S equal to either success or failure. So in binomial distribution, only two possible outcomes. So X takes the values 0 to N. So what is X? X is number of successes. So in a random experiment, whatever the success event we are defining, so in that, what is the number of successes? If in any trial there is no success, then X takes the value 0. If only one success happened, then X equal to 1. If two successes happened, then X value is 2. And so on. X takes N number of successes. What is N? N is a number of times the random experiment is performed. Suppose a coin is tossed. So here that coin tossed is performed suppose 6 times. So the random experiment performed 6 times. So N equal to 6. So the number of times the random experiment performed is N. And P is probability of success. Probability of success is denoted by small letter p. So what is the probability of success? That is depending on the event defined in that random experiment or success event defined in that random experiment. Suppose a coin is tossed in that random experiment, I am defining the success event as occurring head. Suppose head occurred, I will find the probability of success. If tail occurred, then that is the probability of failure. So only the head occurred is the success event and remaining all failure events. So in binomial distribution, that's why it contains only two outcomes, either success or failure. That success event depending on the event defined in that random experiment. So here N is a number of times the random experiment performed and X is number of successes and P is probability of success in a single trial. How many number of times the random experiment performed, even though we find the probability of success for a single trial. So what is the probability of getting head in when tossing a coin? So probability of getting head is 1 by 2. In the second time again I performed that same experiment. Again the probability of getting head is 1 by 2 only. There is no change in the probability of a success event for any trial. So how many number of times that random experiment is happened, but the probability of a success event never changes from trial to trial. So even a single trial we find the probability of success. And here all we have discussed whatever the properties of binomial distribution. That is, again here probability of success is denoted by small p and probability of failure is denoted by small q, and the total probability p plus q equal to 1. So here q equal to 1 minus p. In binomial distribution, the parameters are n and p. That means the random variable x follows binomial distribution with the parameters n comma p, where n is a number of trials or number of times the random experiment happened, and p is the probability of the success event which we defined in that random experiment, and total probability is 1. So that's why once we know the parameters n and p, and we can find the probability of any number of successes by using this formula, that is p of x equal to ncx p power x q power n minus x. This formula is applicable to find the probability for any x value and only for 0 to n, that is a finite number of trials only. Since this is a discrete random variable binomial distribution, in that the random variable x takes a finite number of values and moreover integers. So x is equal to 0, 1, 2, 3, so on n. N times the random experiment is performed, that's why x takes the values up to n. And remaining at all other values, the probability is 0. So this probability is called probability mass function of binomial distribution. Now, what are the statistical measures we find in binomial distribution by using the probability mass function, that is p of x? Is the first one is mean, that is denoted by mu equal to np. N into p. N is a number of times the random experiment is performed, and p is the probability of a success event defined in the random experiment. So n into p is the mean of the binomial distribution. And variance. Variance is denoted by sigma square and it is defined as npq in binomial distribution. Again q is where q equal to 1 minus p, since the total probability p plus q equal to 1. And moreover, in the binomial distribution, only two possible outcomes, that is success or failure. So what is the probability of success? If we know probability of success, we can find the probability of failure from the total probability p plus q equal to 1. So next, mode. Here mode is defined in two ways, that is n plus 1 into p and n plus 1 into p minus 1. This is two modes. If n plus 1 into p belongs to z, if it is an integer, then it takes two modes, that is n plus 1 into p and n plus 1 into p minus 1. So bimode. So bimodal distribution this is. If n plus 1 into p belongs to z. Suppose it is a not belongs to z, that is a rational number, then we take the integral part of that n plus 1 into p. That means only integral part, we ignore that decimal part of that number. So this mode depends on n plus 1 into p value. If it is an integer, it is a bimodal. If it is not belongs to z, that is a irrational number, then it takes only one mode. Now we see the examples on binomial distribution, how to find the probability of different values of x and how to find the parameters n and p and mean, variance and mode also. So here determine the binomial distribution for which mean is 4 and variance is 3. So this is the data and also find mode. So already we know that the parameters of a binomial distribution are n and p. If we know these two values, we can find the probabilities or any statistical measures like mean, variance, mode. So here also, what is the data given in this question? Mean is 4. Mean is denoted by mu. Mu equal to the formula for binomial distribution to find mean is np. So that value is given, which is 4. So take this as equation 1. And also given that the variance of the binomial distribution is 3. Variance is denoted by sigma square and the formula for variance in binomial distribution is npq, which is equal to 3. So take this as equation 2. Now we have two equations. If we solve these two equations, we get the values of n and p. So here np equal to 4, npq equal to 3. So substitute equation 1 in 2, then we get q equal to 3 by 4. And we know that p plus q equal to total probability p plus q equal to 1. If q equal to 3 by 4, we can find p equal to 1 by 4. 1 minus 3 by 4. So 1 by 4. So this p is probability of success. And now we find n value. Since already given that np equal to 4. So from first equation, we can find the value of n by substituting p equal to 1 by 4. Then we get the value n equal to 16. So n equal to 16, p equal to 1 by 4. These two are the parameters of binomial distribution. Now what we have to find? So find mode also. So we can write mode definition is here n plus 1 into p. First we calculate to find mode what is the value of n plus 1 into p. N equal to 16, p equal to 1 by 4. Substitute that value 17 by 4. This is a rational number. So rational number means in decimal form we get. So we take only the integral part. Ignore this decimal part. So that's why the mode is 4. And we say that determine the binomial distribution means the binomial variable capital X follows binomial distribution with the parameters n comma p where n equal to 16 and p equal to 1 by 4. This is the binomial distribution from the given data. The next example, 2 dice are thrown 4 times, getting a sum 7 on the faces is a success. So here the success event is defined. Find the probability that the sum 7 gets twice, never, only once. So these probabilities we have to find. So what is the random experiment performed here? So the random experiment is 2 dice are thrown 4 times. So this 4 is finite value. So that's why this is a discrete random variable. And moreover, the random experiment is 2 dice are thrown. 2 dice are thrown means here 36 possible outcomes. So the sample space contains 36 possible outcomes and this is a binomial random variable. So here the data is n equal to 4. Number of times the 2 dice are thrown is 4. So that's why n equal to 4. And the success event, capital X is defined as the success event sum 7. When 2 dice are thrown, how many number of times out of 36 the sum 7 will get? So here the probability of getting the sum 7 is 6 times. So out of 36. So that is 6 by 36. This is probability of success. So probability of success is denoted by P, which is equal to 1 by 6. Sum 7 means we write them as 1 comma 6, 2 comma 5, 3 comma 4, 4 comma 2, 5 comma 2, 6 comma 1. These are the possible ways to get the sum 7. So that's why the total possible cases are 6 out of 36. So that's why probability of a success event is 6 by 36. 6 by 36 means we can write it as 1 by 6. So probability of a success is denoted by small letter p. Remaining all other cases, the failure events. That means not getting the sum 7. Those are all failure events. So here we defined the success event as getting the sum 7. Now here n equal to 4 number of times the random experiment is performed and p is 1 by 6. Now x, the random variable, follows binomial distribution with the parameters n is 4 and p is 1 by 6. Once we know the parameters, we can find the probability of any number of successes. So here, what is find the probability that 7 gets twice. So out of 4 times, how many number of twice? That means 2 times. What is the probability of getting 7, sum 7? What are the chances to get the sum 7 out of 4 times? 2 times. So that's why probability of x equal to 2. So here x takes the value 2 or x is equal to 2, or it can be simply denoted by probability of x equal to 2 or p of 2. All these are same notations. So here p of 2 equal to, here NCX, p of probability mass function of binomial distribution is NCX p power x q power n minus x. So here x is number of successes. Number of successes are 2. So x is equal to 2. So x is 2, n is 4, p is 1 by 6, q is total probability is 1. So p plus q equal to 1 and q equal to 5 by 6. So total probability 1 minus p is 1 minus 1 by 6 is 5 by 6. So q is 5 by 6, p is 1 by 6, x is 2 successes out of 4. So what is the probability of getting exactly 2 successes out of 4? We apply this formula. Then 4 C2 1 by 6, x is 2, 5 by 6, 4 minus 2 whole square. So after simplification we get the probabilities. This many chances are there to get the sum 7 2 times out of 4. Similarly, never. Never means out of 4 times there is no success. That means x takes the value x is equal to 0. All 4 times other than sum 7, remaining sums will get. That is sum 2, 3, 4, 5, 6, 8, 9, 10, 11, 12. So these sums may get, but all these sums are failure events. Only the success event is getting the sum 7. So here never means except 7, remaining all sums will get. So here x takes the value no success. No success means x takes 0. So x is equal to 0. What is the probability of no success? So p of x is equal to 0. Again, the same formula, that is probability mass function of a binomial distribution is NCX p power x q power n minus x. X is equal to 0, n equal to 4, P equal to 1 by 6 and Q equal to 5 by 6. Substitute all the values. 4C0, 1 by 6 whole to the power 0, 5 by 6 whole to the power 4 minus 0. After simplification, we get the probability as 0.48. The last one, only once. Only one time. That means out of 4 times, only one time, what are the chances of getting the sum 7? So P of x is equal to 1. We denote it as P of x is equal to 1. Exactly one time. So that is again x is equal to 1, n is equal to 4, p equal to 1 by 6 and q equal to 5 by 6. Apply the same formula for probability mass function of binomial distribution ncx p power x q power n minus x. Substitute the values, we get the probability of getting exactly only one time or only one success out of 4 times. That is 0.386, or if we correct up to second decimal, then we can write it as 0.39 also. The next example, 6 dice are thrown 729 times. How many times do you expect at least 3 dice to show 5 or 6? Suppose a die is thrown, then the sample space contains 1, 2, 3, 4, 5, 6 outcomes. These are the possible outcomes. But in binomial distribution, we define the success event is the success event and failure event. So here success event is getting 5 or 6 is the success event. Remaining all other events are failure events. That means getting 1, getting 2, getting 3 or 4. All these are failure events except 5 or 6. So the success event capital X is either 5 or 6 is the success event. So what is the probability of getting 5 in a single trial? How many number of times this experiment is performed, we find the probability of success for a single trial only. That means this probability of success never changes from trial to trial. So that's why probability of getting 5 is 1 by 6. And probability of getting 6 is also 1 by 6. So probability of 5 or 6 is 1 by 6 plus 1 by 6, which is equal to 2 by 6 means 1 by 3. So this is probability of success, which is denoted by small letter p and which is 1 by 3. And moreover, we know that the probability, total probability is equal to 1. So p plus q equal to 1. So from this equation, q equal to 2 by 3. So P equal to 1 by 3 and Q equal to 2 by 3. Now here 6 dice are thrown. A die thrown how many number of times? 6 times. So that is the small n value. So n is finite. So that's why we apply binomial distribution. If n is finite, then only we apply binomial distribution. Suppose n is large, then we can't apply binomial. So that's why here n equal to 6 means a finite value. So we apply binomial distribution. So here 729 times means here 6 dice are thrown 729 times. That means 729 persons performed this experiment. We can assume like that also. So here capital N is 729. Number of persons performed this experiment is 729. So that's why capital N. Now what we have to find? How many times do you expect at least 3 dice to show 5 or 6? 3 dice means out of 6 dice, how many? Exactly 3 dice show either 5 or 6. That means what is x value here? X is equal to 3. 3 successes out of 6. Out of 6 successes. That means X takes no success. No success means 0. Out of 6 times no success occurred, that means either 5 or 6 occurred. So that's why X is equal to 0. Only one time occurred, either 5 or 6. 2 times occurred, either 5 or 6. 3 times occurred, either 5 or 6. 4 times occurred, either 5 or 6. 5 times occurred, either 5 or 6. 6 times occurred, either 5 or 6. Since 6 times that die is thrown 6 times. So that's why X takes the values 0 to 6. 0, 1, 2, 3, 4, 5, 6. These are X values. But here the question is, what is the probability of getting at least 3 dice to show 5 or 6? So at least means maybe 3 successes or 4 successes or 5 successes or 6 successes. At least 3 means minimum is 3, maximum is 6. Since 6 dice are thrown, so that's why X takes the values from 0 to 6 from the definition of probability mass function of binomial distribution. So that's why X takes 0 to 6, but we have to find what is the probability of getting at least 3 dice to show 5 or 6. Already we know that the probability of getting 5 or 6 is 1 by 3 for a single trial. Now we find at least 3 successes, that is probability of X equal to 3 plus probability of X equal to 4 plus probability of X equal to 5 plus probability of X equal to 6. So these probabilities we have to find. Instead of finding all these probabilities, we take the total probability 1 minus, total probability is 1 minus whatever the values missing, we subtract those values. Probability of X equal to 0 plus probability of X equal to 1 plus probability of X equal to 2. Both the cases are same. You can find all these probabilities, or we can take the total probability and subtract the remaining missing values of X, that is 0, 1, 2. So 0, 1, 2. Find all the probabilities, and the probability mass function is P of X equal to NCX P power X Q power N minus X. So take X value as 0, 1 and 2. Find the probability. Then 1 minus, subtract from 1, we get the probability is 233 by 729. So this is probability of getting at least 3 successes out of 6 successes, where the success event is getting 5 or 6. Now what is the expected number? Expected number means frequency. So frequency is, expected frequency is capital N into P of X. Capital N into P of X. Capital N is total 729 persons performed this experiment. How many can expect? So that's why capital N into P of X. P of X is 233 by 729. So capital N is 729 into P of X is 233 by 729. We get 233. So 233 persons may get at least 3 successes out of 6, where the success event is either 5 or 6. The next distribution is Poisson distribution. This is also a discrete distribution. That means here the random variable capital X follows Poisson distribution with the parameter lambda. So before knowing that lambda, what is the probability mass function of Poisson distribution? What is the difference between binomial and Poisson distribution is, in binomial distribution, n is a finite value, number of trials or number of times the random experiment is performed, that is a finite value in binomial distribution. In Poisson distribution, n is a infinite value or large value. Then we apply Poisson distribution. So what is the probability mass function of a Poisson distribution? So P of x. To find the probability at any value of x, P of x is equal to e power minus lambda into lambda power x by x factorial, where x is equal to 0, 1, 2, so on. So here n is infinite value or large value. So that's why x takes infinite. We apply Poisson distribution. So here e power minus lambda into lambda power x by x factorial. Again, x is probability of success in that random experiment or any situation we can take, or we can define it as a random experiment. So x follows a Poisson distribution with the parameter lambda. So in binomial distribution, the parameters are n and p. In Poisson distribution, the parameter is lambda. So what is lambda? Lambda equal to n into p. P is the probability of success in a random experiment, and n is the number of times the random experiment is performed. Here n is large. N is large and p is small. Very, very small. So that's why n into p is a finite value. So that's why lambda is finite. If we multiply a large value with a very small value in decimal form, probability means in decimal. So we multiply this, we get the finite value only. So that's why lambda is a finite value. In some problems, they will give n value or p value, or directly they will give the parameter lambda also. So if we know the parameter lambda, we can find the probability of any number of successes or at any value of x. So here n is very large, probability is very small. So that's why lambda is finite value, where lambda is a parameter of Poisson distribution. These are all properties of Poisson distribution. Now how to find the statistical measures in Poisson distribution? So here mean equal to lambda. Mean is denoted by mu equal to lambda. Variance sigma square equal to lambda. In Poisson distribution, mean equal to variance equal to lambda. And mode. Mode is mode is depending on the value of lambda. If it is between lambda and lambda minus 1, here also we have two cases, that is, if lambda is integer, then bimodal, that is lambda and lambda minus 1. Two modes we get. If lambda does not belongs to z, that means a rational number, then we take the integral part of lambda. Then that is unimodal. In that case, unimodal. If lambda belongs to z, that is bimodal. Now we have discussed the properties of Poisson distribution. In the next class, we see the examples how to find the probabilities in Poisson distribution. Thank you.